Hi, I'm Kobus Marneweck from Arm, and today we're going to have an interesting panel discussion on voice control made simple. With me, I have some experts from some of our partners, and the format today will be, I will do a short introduction of our participants, and then each one will give a short overview of what their companies do to enable simplification of voice control solutions. We'll also discuss a few other topics, and then in the second half of this roundtable, we'll open it up to a Q&A, and you can ask any questions to the panelists. So with that, I will introduce our panelists. As I said, my name is Kobus Marneweck. I'm a senior product manager at Arm, responsible for go-to-market strategies with partners, and I previously managed several Cortex-M products. I work closely with our silicon partners to promote Cortex-M and Cortex-A and technologies such as security, signal processing, machine learning, and AI to enable secure, low-power compute on IoT devices. I have a long history in IoT and connected devices, and I also spent 11 years at Microchip, 5 years at TI, various other semiconductor startups as well, and I was involved in the early Bluetooth Low Energy and Zigbee developments. With me on the panel is my colleague Christian Roussel from Arm. Christian is a senior solution architect in the Arm Partner Enablement Group. He's mostly involved in the embedded IoT and automotive space, where his main role is to provide guidance to Arm's OEM customers on Arm-based SoC system architecture. He's also deeply involved in promoting Arm technology in the ecosystem through proof of concepts in collaboration with our partners. Prior to joining Arm, Christian was lead SoC architect at Texas Instruments and Samsung, in charge of mobile phone application processor architecture definition. I'm also joined by Robert Tan from Cambridge Consultants. Robert has spent more than 20 years with Cambridge Consultants designing products and solutions for a vast range of ambitious clients. Robert has a background in audio processing and radio PHY development for cellular and satellite communication systems with a focus on low power implementations. He is now head of the signal processing and AI at Cambridge Consultants, and as part of the Arm partnership, his team has been given early access to the M55 and U55. He has also been investigating what applications can be enabled by this new technology, including moving AI processing from the cloud to the edge and low power on-device voice processing. We're also joined by Jeff Rogers from Sensory. Jeff has been involved and influential in the development and design of hundreds of products over the last 26 years using speech and computer vision technologies. Jeff focuses on how to implement sensory technologies into real-world products and has played an important role in Sensory's success in the market. Sensory has licensed speech and computer vision technology to companies such as Amazon, Google, Samsung, Microsoft, Huawei, Lenovo, and many more. And finally, we're joined by Vikrant Tomar from Fluent. Vikrant is the founder and CTO of Fluent. He's a scientist and executive with more than 10 years of experience in speech recognition and machine and deep learning. He obtained his PhD in automatic speech recognition at McGill University in Canada. We worked on manifold learning and deep learning approaches for acoustic modeling. In the past, he's also worked at Nuance Communications and Vestec as a research scientist. So next, I'm going to turn it over to our panelists to give a short overview of what their companies do to help make voice control simple on the edge. So let's start with Christian. He's recently published an excellent white paper, which can be downloaded from the Arm website. Christian, can you tell us what you do in this field?
So yes, if we look back, I mean, speech recognition have been, here for decades. Speech technology have been here for decades. But if we look in the past 2 to 3 years, we've seen a massive increase of the application of voice assistants, and especially with the emergence of natural language understanding, an application like smart speaker, we see a huge market growth in the speech recognition solution. So most of the application we have seen so far are based on NLU engine, natural language understanding engine, hosted in cloud, most of the case, hosted by cloud providers that offer some specific frameworks on which you can custom your application for a certain domain, like smart home appliance, like smart light switch. Device manufacturer can use those framework to create specific device, speech recognition engine for those applications. So most of those solutions runs on smart speaker or maybe some dedicated application. There is already some application that also supports natural language understanding without cloud connection, and especially in the wearable application, there is we can see already some great application where speech recognition is accessible without any internet connection. But we see a lot of coming application where some customization, some optimization will be required, whatever it's for cost reason or power reason or system optimization, like reducing the cost of the connectivity. We see a lot of new opportunity for voice solution. So if we look to smart speaker, up to now, smart speaker, there are devices that are plugged in, access to significant power. They may have some combo application like loudspeaker, great audio user experience, or video. And usually those applications run on quite significant powerful MPU, running high-level OS. So it's more or less Cortex-A class of device, equivalent to chipset like we find in mobile phone, where there is also some voice assistant, by the way, solution. So Cortex-A class of device running high-level operating system with significant needs of memory and overall system solution. What we want to talk today is how we can enable efficient voice solution on more constrained devices. And more constrained devices, we are now talking about microcontroller with much less memory, much less megahertz, but that will offer significant improvement in terms of power, in terms of cost figure, in terms of system flexibility. Obviously, we are not, there is no magic. We will have to do some compromise. Smart speaker are usually devices that stand in the middle of the room, on which to which you can speak more or less at 360 degrees. So they have strong audio capabilities thanks to their strong computing resources. Here we are talking about new application where the user may be located closer to the device. We are not necessarily talking about far field, but near field, which means below 1 meters. Limited number of microphone as well. So like, smart appliance could be a smart fridge on which you want to talk, or a smart switch. You will be closer to the device. And so we will looking at what sort of optimization we can do in the voice capture, but as well in the speech recognition of the device to enable still valuable user experience, but on a more constrained device. So what we are talking here about is to enable those voice solutions on Cortex-M type of devices, MCU powered by Cortex-M, from a Cortex-A where devices can run at gigahertz range. We are talking here about MCU that will run in the 200 megahertz range with memory architecture below 1 megabyte of flashes and a few hundred of kilobytes of static RAM. Okay, so all those different solutions, MCU solutions, are available from our SIP partner, and we will see with our today panelist how we can integrate the various components of the system for a voice speaker. So we are talking about the audio front end. We will address that part. We are talking about the voice recognition engine, the keyword spotting, and we will address that part. And as well, maybe the security aspect and the connectivity aspect.
Thank you, Christian. Next, Robert, I know you've been doing some interesting work in this field, and maybe you can also talk about some of the work you've been doing on the Cortex M55 and U55, and what the future holds for when utilizing these new CPUs and NPUs.
Yes, thank you, Kobus. So, I mean, I'm sure a number of people listening know Cambridge Consultants, but for those that don't, we have a bit of a unique role within inside the ARM ecosystem, in that as a technology consultancy, we are concentrating on creating breakthrough innovation and products for our clients. So we're kind of independent. We're not here to sell a particular piece of IP or a particular library solution. What we're interested in is solving the whole problem, the whole solution space for our clients. So if that needs an ASIC, then we can help them develop that. And if that needs a low power optimization, we can help them with that. Or if it's integration into a wider service, we can help with those things. But that means that we're looking at voice control and indeed audio and edge AI technologies through the lens of that whole system design and the options that you need to determine the best platform or IP or architecture for a specific development. Can you choose a platform that's not only good for the voice control, but that's also good for the action you want to take once you've detected that vocal intent? And that's one of the reasons why we were so keen to look at the M55 and U55. People may have heard that a couple of years ago, we developed a very low power voice activity detector, and that complemented an ARM processor, which we were then using, an M series that we were using for the keyword detection. And we wanted to know what happened when that moved to one of these new platforms, the M55 and the M55 U55 combination. And one of the things I think that was everyone expected is it would be faster. They're more powerful platforms, but I don't think people realize just how much. Relative to the M4, for example, this was about 100 times faster by the time we got the M55 and U55 in combination for admittedly quite a simple keyword neural net, but the impact was larger than expected. What is probably less intuitive is that if you chose the architecture correctly, these bigger, more powerful cores would also result in lower power solution. Putting it quite simply, they got through the task of that keyword detection quick enough for us then to drop into a low power state, and the overall always on profile ended up being much more efficient. And of course, when it triggers, the M55 and U55 also gave the potential of this large amount of local compute. So the applications that you might be able to enable, had much more possibilities. And in fact, one of my colleagues, James Pete, is presenting the session tomorrow, 10.5, on that path to what things you might be able to move from to low power AI at the edge. But the possibilities of moving something very complicated or very large neural nets to the edge, and that's sort of the interest for me is where the voice control sits within inside the whole solution space, how you marry the architectures to work well for both. I think the other point inside that is for voice specifically, there's a front-end audio interface, and there's a whole load of things that have to happen before you hit the voice control. And it's different if you want to also listen or record that voice, or if it needs to go across a compression or a codec system, or eventually needs to be transmitted. So you need to know those parts of your application. And for things like feature extraction, those signal processing tasks, where in the past you may have wanted to put something in that was specific to that hardware acceleration, for example, because it's on always the time. Some of the new platform technologies, Helium extension, for example, challenge where those architectural boundaries should be and what should be always on a platform. So for us, it's quite exciting to see the change in the platform technologies and the possibilities that brings to product development for our clients.
Thank you, Robert. Next, we'll turn it over to Jeff. Jeff, I know you've got a long history in this field, and maybe you can tell us a little bit about what you've seen in terms of the how this has progressed and where you think it's going as well.
Yeah, thanks. Good morning, everyone. It's great to be here on the panel with Arm and the others. Just a quick intro to Sensory for those that don't know us. We've been improving the customer interaction with products for more than 25 years today, and we do that through speech and computer vision technologies. Our focus has always been AI on the edge, doing everything on the edge, so we don't have to worry about the cloud connectivity or privacy or other issues that can come along with the cloud. We actually started the company in '94 as a chip company, making little 8-bit microcontrollers that could run speech technologies. And I love the topic of this panel, voice control made simple, because back in '94, when I was selling speech technologies back then, I'd walk into a room and I'd kind of look at the acoustics of the room, and I'd look at the other people and be like, okay, I'm going to demonstrate speech. Everybody stop talking for a second. And it was challenging back then. And we were doing all this on a little 8-bit microcontroller. And so today, there's so many more opportunities, both in the improvement of the technology, but also on the platforms that we run on today. Our technology ship in more than 3 billion products worldwide today. And Kobus mentioned some of our customers: Amazon, Google, Microsoft, Samsung, Tencent, Honda, Huawei, etc. And it's a lot of different markets that we play in, but it gives us a lot of different experience, and we bring that experience to whether it's an automotive application or it's an IoT or it's an appliance. We play across all of those games with this focus on we want to provide a very natural user experience on the edge. We support more than 20 different platforms today, chip platforms today. So we no longer are a chip company. We fortunately let the chip guys focus on that. And today we run on a variety of different platforms, and a lot of those are obviously ARM based. And so we very much appreciate our close partnership with ARM. Last month, with our close partner ST Micro, we did a webinar where we actually introduced our truly natural engine. So this is a large vocabulary recognizer that all runs on their H7 processors, which are based, of course, on the M7. So this is a chipset that has no OS, and yet it had a vocabulary of over 10,500 unique phrases that we could say to this device. And that whole thing fit in about 1.5 megabytes. So in technical terms, that's freaking awesome. And again, I had this ability just to speak naturally to this demo. I noticed that the Fabware microwave oven is officially on the market today. And this microwave oven uses our truly natural engine as well, and allows the user to basically get the product, get it home, plug it in, and start using it. There's no apps to connect to, there's no Wi-Fi to connect to, there's no syncing the product to some application, to my Amazon or my Google account. No, I buy the product and I use it. So voice control made simple. Yeah, that's simple. Plug it in and start speaking to it. This microwave has a huge vocabulary, and I can say things like cook for 35 seconds, or defrost a 2-pound chicken, or set timer for 10 minutes, or set the time for 7:45 a.m. Whatever. It's natural language. So from Sensory's perspective, we provide not only the natural language engine, but also custom wake words and multi-wake words and phrase-spotted command sets. Again, the topic of voice control made simple. I love it because voice control has a long history of being everything but that. You've got to collect data, and you've got to deal with accents, and you got to deal with dialects, and you got to deal with real-world environments, not just the lab. You got to deal with real-world people and users, not people that know how to use speech technologies and know when to speak and know when to shut up and know when to make sure that others are. None of those things work in the real world, and so you have to have products that go across those. And so from Sensory's perspective, whether it's our natural language engine, our custom wake word engine, our phrase spotted engine, or our biometrics, voice and computer vision, they all have to work in these real world environments. So our voice hub it goes right along with the title of this panel. Voice control made simple. Our voice hub makes voice control simple. Voice hub is a free online portal that anyone within the sound of my voice right now could basically create a custom wake word or multiple wake words in a variety of different languages. It supports more than 12 languages today out of our 24 languages that we support in total, or a phrase spotted command set, or a natural language grammar. And You basically type in what you want, you hit the build button, and in about an hour, it comes back and says, okay, your wake word or your phrase spot command set's ready, or your natural language grammar happens within seconds. And now I can test it immediately on the PC. I can download it onto Android or iOS device and test it there. So I have this ability now to create something and then immediately test it and say, okay, do I like the flow? Nah, I'm going to change these commands here because this flow might be better. So from a marketing perspective or a product ideation perspective, it makes it much simpler. We certainly have a focus on low power. We've been doing low power for a long time. We pioneered most of the low power, always on wake word technologies that are in the market today. When we look at so we're really excited about the M55 processor with the Helium neural net processors that go on there, because if you look at a comparison, so we can run on the M4, we can run on the M33 and the 55 and the A series and the M7 series, of course. But if I do a comparison between the M4 running our 1 megabyte wake word model, that takes about 200 megahertz. If I run that same wake word model, that same 1 megabyte wake word model on the new M55, I go from 200 megahertz to 50 megahertz. So I still get the advantage of the value of that large engine, that larger model, 1 megabyte, but I'm running it way down at 50 megahertz. So I get much lower power. So as an example, Samsung TVs in their remote controls, these remotes have to be on and listening 6 months on 2 AAA batteries. And that requires obviously super low power. And so these new processors are really going to help in that. So voice control made simple. Yeah, excited about that. And our Voice Hub really does make voice control simple. Thank you.
Thanks, Jeff. And last but not least, Vikrant Tomar. I know Fluent has done some interesting work and especially in terms of driving down the resource requirements to enable a very rich user interface. So Vikrant, tell us about what Fluent does.
Thanks, Kobus, and thanks everyone. Happy to be here. Yeah, so I think it's a very interesting topic, as Jeff said. There's a lot of innovation coming from hardware side. What we started at Fluent side really is to just look at how fundamentally speech recognition has been done. Like, speech has been around for a while. In fact, I like to joke that speech is one of those technologies that's been around, that's been 5 years away for the last 30 years, right? We've been saying, like, yeah, it's going to be here, but it's not been here. But recently, with the innovation in deep learning, with neural net stuff, now we are able to see obviously a lot of views around us. So Fluent started with the idea to see, like, okay, everybody around us is doing speech recognition in a way that goes from speech to text and then try to extract meaning out of text using natural language processing. And it's a great approach. It works well. It's been working. But is there possible or are there possibilities to improve this? And how can we improve this? Or maybe there are some shortcomings in this. So one of the things we looked at is how could we simplify overall the speech recognition and understanding process. So we came up with these new kind of methods that what we call end-to-end spoken language understanding, where the system does not need to transcribe what the person is saying. So think of it like kids, right? Kids, before they go to school, they don't know how to read or write, but they can still understand you, what you're saying, right? So in a lot of use cases around us, for example, a doorknob, right? Like, why, when you say open the door, like a smart lock or unlock it for me, whatever is your phrase, why does it have to transcribe that into text? Or why does it even need to send it to the internet? Like one of the other interesting thing we're interested in today, right? So Fluent started with this idea, like, what if we could design speech interfaces that directly is able to extract meaning from the voice? And the advantages of that, beyond just like, hey, overall simplifying this speech understanding process, is that we're able to design systems that are very, very low power. So some of this work that we've done in wake word, the wake word engine is able to run around some 30 megahertz on a Cortex M4 microcontroller, uses less than 100 kilobyte of RAM, and still is able to provide state-of-the-art performance, meet or exceed the benchmark that is defined by Amazon for the AVS services, right? So that's one example. We've done a lot of work, and again, like, how can we bring the naturalness of like a person being able to just go up to a device and just say a command in their natural voice, like without having to remember, oh, do I say turn on or do I say switch on? That's typically found in these internet connected devices. But how could you bring that to very, very low power devices? That's been another one of our focus. So we've done one example is like on Cortex M4, we are able to do up to a few hundreds of commands on an M4 device running at 96 megahertz, very, very low power, but a person is able to go to that device and say their phrase in their in their vocabulary without having to remember switch on the light versus turn the lights on like that, right? So it's really derive that natural user interface, but even on offline devices. The other interesting thing where we've really focused on is like, okay, today, if you look at speech recognition in North America, it's very accessible. In maybe other English-speaking countries, it's fairly accessible. In China or Mandarin, because there's a lot of companies, there's a lot of innovation there, it is accessible. But what about the rest of the world? Rest of the world, there's very little speech recognition available in other languages. And what are the challenges for that? So one of the challenges is obviously the conventional approaches. There's a lot of data requirements. So sometimes the cost that goes in developing those systems because of data, et cetera, does not justify the return. So those are not done. With our technology, we've been able to develop systems that can very quickly learn a new language and is able to function in this new language. We have, in fact, designed systems that are able to recognize up to 3 languages. We had, well, for one of our customers, we did work in German, Korean, and English, 3 very different languages running on a single system. It was a Cortex M7 running at I think about 200 something megahertz. And the user does not have to choose the language. They just go to the system and speak in the language of their choice, right? And the system is able to recognize them with high accuracy. So this is, for us, has really been motivating us to bring the voice user interface interaction or the interactability or the experience to not just a handful of people, but around the world, create the accessibility where maybe people don't have internet. Like one of the things I spent last few months in India, for example, like that's where I'm from. So taking advantage of Corona, just work remotely, everybody's working there, right? So, but there is 4G everywhere. I had 4G connectivity all the time, but if on my phone, I'd be like, hey, Siri, do something for me, or ask like, what's the weather? And Siri is hanging there, even though it's connected, right? Like it's just not able to, the latency or the connectivity definition, it also changes from one region to another region, right? So this is where being able to develop natural interfaces directly, those that could work offline on the device, that's been our passion, and that's kind of where we've been pushing it forward.
Okay, thank you. You know, we're talking about voice control made simple, and I think a lot of the people that are attending the session may be new to voice and thinking about how can they add voice to their product. And I'm going to open it up to all the panelists and maybe discuss, you know, what's the best practices and where do you start to investigate what is the best solution for my specific use case. So I'll open it up to anyone that want to jump in and maybe.
I'm happy to comment on that one, Kova. So I think the best place to start is you always have to define what are you trying to accomplish? What's the product? Is it a wearable? Is it something in the car? Is it an appliance? Is it IoT? Because those will have different requirements in terms of processing power. Does it have to run on a battery? Can it be plugged in? What's the use case? You know, if it's a hearable, then it's something that I inherently will have better signal to noise ratio. But if it's an IoT device across the room where I have to recognize from 4 or 5 meters, that's a very different type of setup. And so for me, when I'm talking with customers, the first question I always ask is, what's the product? What's the use case? How are people going to use it? And then that defines the hardware. Should we focus on an M4? Should we focus on the M55? I mean, the M55 is going to run a wake word really, really well in a smaller command set. But the M7 or the M4 is going to run a larger vocabulary engine better. So again, depending on what you're trying to accomplish, that's going to define what hardware should we focus on, and then how should we design that set? What's the technology? We talk about speech recognition. We can have a fixed wake word that works right out of the box. We can have a user-defined wake word where somebody defines it themselves, or an enrolled fixed wake word where I want to have speaker ID. So again, there's a lot of cool technologies that are out there today. And for me, the first part is always, what are you trying to accomplish and what are the requirements? Because if it has to be really small, it's got to be really small. We got to focus on hardware that way. Or if it's something in the car, I might be able to take advantage of the processors that are there.
Yeah, if I could add on that, there is like for us, it's been the same. Like we have to work very closely with we need to work very closely with the customer to understand what the exact use case, the exact user as well, demographics, who's going to use it, the environment. Often you have to make a choice between, do I need to use a audio front end to remove noise, or do I need to save on the power consumption? What should be my proper microphone choices that's going to work in this environment? Is it something that's closed talk? Could we use directional microphone or not? Are there going to be, like, for example, for one of our customers, we're working in a factory environment where they want to control different machines using the voice, but there are multiple operators on the same floor. So now one of the challenges is like, okay, so these 10 people, 12 people, they're going to be in a very close proximity giving commands to their individual devices. How do you ensure that my command is not interfering with the other person's command? So you have to work with the customer or work closely with each other to design a solution that fits the need.
Yeah, I'll just add to that. I mean, I absolutely agree with both those. You need to understand the environment and the requirements. I think one of the things that can trip people up with voice and with Edge AI, actually, for that matter, in general, is that some of the techniques that you'd normally do for things like platform evaluation, which processor are you going to use, the things that might work well for signal processing or for software architectures in terms of measuring MIPS and bottlenecks around data or latency. For AI, the nuances of that are quite vast as to whether a platform and a tool chain, a whole tool chain from your model through to implementation, is going to work well. And so I think one of the best practices for me is to do that evaluation up front, to know your requirements, as Jeff said, yes, but also to look at the different options that you've got available to you, because it's not as obvious as to how you choose one path over the other. And things like flexibility that people love to say they go and build in flexibility, so in the future they might be able to work with, I don't know, a different microphone or a different vocabulary set. That's not as obvious as to how you'll take those architectural decisions into account at the point you're choosing your platforms. So when we talked about simple voice recognition, one of the things I liked about what Vikrant and Jeff have said is I'd like it to be simple for the developers as well, not just simple for the users.
Christian, can you maybe talk a little bit about resources that are available for people that want to get started with a voice-enabled product?
Yeah, sure. So just to complete what the panel said here, we are we obviously encourage all our partners to go and review with our partner or solution partner effectively all the dimensioning of their system. And you just mentioned for voice solution, the key aspect of the acoustic environment. Effectively, a key element in a voice capture system is the audio front end, and selecting what type of microphone array, whatever it should be, 1, 2, 3, or 4 microphone array is a quite difficult task. So that's why we in ARM have been going through that pain with our partner, try to put in place the minimum requirement for such system, but obviously each system is particular, and we definitively encourage our customer to review with our partner all the element of the audio front end and the keyword detection. One key element, by the way, is that all the components are linked together. You cannot obviously design your keyword spotting, NLU engine recognition without putting in the loop your audio front end that may affect all the audio pipes. So it's a quite complex process here. And yeah, going back to our partner, review your system definition to get your high-level requirement in terms of computing is the right way to do it. In ARM, what we have done effectively is to provide a proof of concepts, a quite simple example of what a 2-microphone voice capture solution could be with an audio front end from one of our partner, DSP Concept, that is connected to a keyword spotting from one of another partners. This is the firmware without those key elements is available on GitHub. It's an example of an implementation, and we encourage our customer to review that. That will give you a good example of how those components needs to be integrated in a Cortex-M device. It's running on one of our C partner platform from Cypress and Finland, an M4, Cortex-M4 PSOX devices. And from the white paper that we have been published, you will find all the different metrics that you should consider, metrics being the megahertz, the memory footprint, to enable such solution. So low cost, 2 microphone, near field solution. The key aspects, system aspect, are not only the megahertz, but the memory architecture, making sure that you will get the full performance from your processor, given the memory architecture won't be limited by your memory architecture. You won't be limited by your peripheral architecture, making sure that getting the samples from the audio pass will be well supported by system DMA and whole pipelining effect to reduce the MCU megahertz consumption. All has been described in this white paper, and we encourage our customer to review this document.
Okay, thank you. And what I just want to add to that is that if you go to the ARM website, you'll find that we have a section there with a lot of other partners as well. And keep in mind that each of these partners may offer a different solution that's more applicable to the application that you want to use. So I encourage you to go and explore that, as well as the resources that Christian mentioned, and take advantage of that to look at your next project. I think at this point we'll move on to the Q&A. And just to remind you, we have a Q&A button. If you click on that, you can ask your question there, and then we'll turn it over to the panel to answer. So so let's start out. Someone said they just checked out the Sensory and Fluent websites. Is there a way to evaluate your technologies?
Yeah, for us, we have a number of demos that we could send you. I'll type in email address, my email address, as well as that of a colleague you could get in touch with.
Yeah, from our side, like Fluent, we have a myriad of demos. So the question is, what is it you want to check out? So is it a wake word? Is it a fixed wake word? Is it a user-defined wake word? Is it a enrolled fixed wake word? Is it our natural language grammar? Is it a voice biometric, our speaker verification technologies, our computer vision? So one of the I guess one of the good things about being in business for so long is we've got a lot of tech. One of the confusing things is we got a lot of tech. So it depends on what you're interested in. For access, I know somebody asked about VoiceHub. So VoiceHub is a free online portal. On our website, there's a requested demo there. And you just enter your company email address, your name and information, and then the system will send you access to that. So it is free access. And again, what that will do is allow you to create custom wake words, custom phrase spotted command sets where I've got 1 to 20 different phrases at the same time, or a natural language grammar. In that tool, I think there's more than a dozen different languages. And I liked Vikrant's example about the customer that needs multiple languages at the same time. That's a really cool feature, and the VoiceHub will allow you to do the same thing, where you can pick different languages, and then within one of our demos, you can mix and match those together. So I've got a demo that combines Mandarin, Korean, and English. Again, pretty different languages, and it's kind of fun to play with.
So one of the questions might be that, someone wants to design a system, and we mentioned, you have an audio front end, you have a wake word engine, maybe an NLP, and then, you have if it's connected to the cloud, you have to have some software to be able to do that. So how do people put these all together from different vendors, open source, some are licensed? Where do they start to put all these things together?
Yeah, it's very actually it's very interesting problem, and often it happens that the customer would come to us and So there are different ways, right? The customer could come to us and they could ask us like, hey, what is the recommended front end, let's say for this particular use case, and then we would work with them. We have a number of different front end partners. I'm sure this is true for Sensory as well. So a number of different front end partners, but we know based on our experience of working with us, which one works best in what conditions, depending on platform, depending on noise types, or other sort of scenarios. So I think the best approach really is to work with the partner, like approach us, one of us, and we would help you sort of help design or give you a number of options or a number of choices. It's because it's very important to not just try to mix and match things. Like often the front end does have a significant impact on the spectrum of speech, and then you may have to require certain tuning either of the front end or of the speech model. So to design a good, compelling system, all different components, hardware, front end, speech recognizer, data, all of these things have to work together. And so this is where first thing we do is we try to understand the needs, and based on those needs, we made certain recommendations. We have had scenarios where we had to work with front ends or hardware that we previously did not have experience with. We did manage to succeed on those, but it took considerable more effort and time, both from our side as well as from the partner side, to get to the same stage where if they had gone with some of our recommendations, then just that getting there would have been a lot quicker for all of us.
Keeping with the panel topic of voice control made simple, one of the ways that we do that at Sensory is that we support a whole bunch of different platforms. So rather than having to say, well, you can only use voice if you're running on this chip or this chip or this chip, there's more than 20 that we support today. The other comment that you made, Kobus, is a really good one. How do you go from on device to cloud? And many years ago, we pioneered this concept that back then we called trigger to search. And the idea was, you know, before we came out with this with Google, you would say the Google wake word, and then you'd wait and would beep, and then you would say the cloud thing, and so you had that kind of that cadence that you had to do. And we looked at that and thought, this is not natural. People aren't going to get this, and so we developed a way to just say the wake word followed by the thing that you wanted, and it's running a circular buffer, and so you have this kind of natural way going from this, you know, from the on-device engine to the cloud without anything between that. And when we first came out with that in the Moto X, Google came to us and said, "Hey, how'd you do that?" And we said, "Not telling." And anyway, since then they figured it out. But you know, there is a real value to the hybrid solution. But I got to tell you, there's also a real value to running everything entirely on device. A few weeks ago, I live in the Pacific Northwest, and we got hit with that snow and ice storm that knocked out power and internet for a week for many people. I didn't have internet for a week. And so all of my Amazon devices, my lights and everything that I've gotten so used to controlling by voice, none of those worked. I couldn't do anything by voice. And to me, it's a real, it was a real wake up to, there's no reason to go to the cloud to turn the lights on and off and to change the temperature and to control the garage door. Let's do all that on device. And then when I did get my internet back on, about 50% of my smart plugs required me to reset that smart plug. So that means get the user manual out, figure out the app again. How do I reset that? How do I get it back on my Wi-Fi? And then I got to rename it. And then I got to resync it with my Alexa. I mean, it was a 10-step process. And I think most people would just be like, forget it. And so while I think there's real value in on-device to a hybrid solution, there's also a huge value into running everything on device, and we can do that now with the processors that are out there.
I'll just add one small thing there. I mean, it's absolutely correct. Like, I think there's a lot of use cases around us that absolutely do not require internet connectivity, but for convenience or other reasons for voice, they have internet connectivity, right? So another one of my jokes about these things is that I would love to see internet out of internet IoT devices, right? Internet of things. Like, you don't need internet in a number of use cases, absolutely for just voice uses around your home. In fact, it's much more convenient if there is not an internet requirement for those. Everything is running offline. Latency as well. Like, it's things are very quick when you can just execute everything on device instead of having to wait for some RTT coming back from the internet.
Yeah, so I think we have to maybe change our thinking a little bit in terms of it's connected and then maybe some local, but to where it's local, and then it can also be connected. So in case you want to control it remotely, you can do that. But in your normal day-to-day, it operates locally to give you the benefits of that low latency. And I mean, I can imagine appliance. It would be kind of silly if you wanted to operate your washing machine and it depended on a internet connection, and so your internet's out and now you cannot use the appliance. So I think there's some thinking of the the manufacturers that have to go into this and not think internet first.
Yes, definitely.
There was that's one of this. There was a few years ago an incident where some of the Amazon voice services were down, and I was just looking at some of the trends on internet, and I'm sure it was a joke, but one guy had tweeted like, "Oh, the Amazon services are down now. I cannot get inside my house because the smart door needed to get to the internet to open." So yeah.
But Vikrant, you also talked about the accessibility around the world, and wireless connectivity is not consistent worldwide. And if we constrain ourselves to only in places which are connected, that actually constrains the use of the products.
Yeah, that's exactly right. The other comment on the cloud engine is most of these are general purpose assistants, which are great if you want to know the temperature on the surface of Mercury and how far is it to between this city and that, random kinds of things. They're really helpful for that. But if you've got if you have an electrical problem, you call the electrician. If you have a plumbing problem, you call the plumber. If you have a roof problem, you call the roofer. And so by using a natural language engine like our Truly Natural Ondevice, we'll build domain specific recognizers. So like the microwave oven, it's really, I mean, the task completion rate is far superior than the one that controlled with Amazon, because Amazon's a general purpose engine that's really, really good at a lot of different things. But for specific, I want to control my microwave, or I want to control my washing machine, or I want to control this device here, keep those specific, make a domain specific recognizer. It's going to be far more successful at a total task completion rate than a general purpose assistant. So I think there's definitely room for both of these engines to ride. But this also brings up the whole idea, and Amazon believes in this with their interoperability, is I can have a wake word that goes to this thing here, and I can have a wake word that goes to my Amazon or my Google or my cloud, whatever. And call the appropriate engine for the appropriate device that you want to talk to, and not try and do everything under one device. That will have more challenges with some of the more specific task oriented things that an appliance might have, or your car might have, or whatever.
We had another question here. I have a voice recognition on my VW car 1918 model. Why is it so useless?
I could tell you, but I don't want to say anything bad about one of our competitors, and it's not Fluent.
Yeah, I don't know about that specific model of car, but I think one of the things that, we've talked about here is when people are doing developments, as soon as you add voice control, you need to do it in testing in terms of the whole system. And we've talked about things like the front end, but actually environment is a big part of audio and voice. And it's one of the more common mistakes to make, is to have not have done development and testing in the actual user environment that things are going to get used in. Jeff joked about, I'm going to demonstrate my voice system. Can everyone shush up, please? And for anyone who's taken a voice demo to a show, you pretty much guaranteed that you're going to be in a room with 100 other people all talking in the background with different types of noise clutter. And speech is one of those wonderful things that all the things you want to eject, like noise and interference, are usually in exactly the same frequency band as all the things you want to accept, because speech includes noise and fricatives that are literally shaped noise. So I think most of the products which struggle integrating voice control just haven't done the testing end to end and haven't introduced that early on in the development.
Yeah, I think in my personal experience, what I've seen with the early voice-enabled products were that they were not good at understanding accents. So, they were tuned to a very Midwestern American accent, and if you if it was outside of anything like that, it struggled. I think that has improved a lot over time. And then the second thing was just that, it seemed like engineers designed a lot of these systems, and especially the user experience in terms of, they said, the way I turn on a light is, I say turn on the light, but then it turns out that people say it in many different ways. And I think Jeff and Vikrant have discussed that. The systems have improved a lot where they are not so rigid to just, where you have to say things in a specific way, in a specific order. And if it's anything outside of that, they don't understand it. So I think those improvements have made the user experience much better. I want to touch on another topic, and that is, if you look at IoT, one thing that I've noticed in the last few years is that with the advent of cheap Wi-Fi modules, where someone could just buy a module, they don't have to go through FCC certification. They buy a module, they plug it into their device, and the module handles the whole TCP/IP stack and the Wi-Fi interface. It has enabled a lot of things. I mean, I have a cat feeder and a robotic cleaner and all these things. So when do you think we'll get to the point in terms of this make voice control easy, where we'll have a voice module where you can plug it in and it takes care of voice for you?
Yeah, I think we're getting closer to that today. A big part of our Voice Hub tool is really to allow right now companies to develop that and to come up with how do I want to talk to my product? And I just type that in, and now I can talk to my product that way. And so from a natural language perspective, you can create your own grammar that way. And I'd call that a simple grammar. Right now, if we want to make it a statistical language model where you basically put some stats behind, if I hear this word, the next word is going to be this one, and the next one's going to be that one, you still need data, you still need examples, you still want to, how do people actually respond to this thing? Is it either through recordings or transcriptions? And that's obviously what the cloud guys do, is they capture all that, and then they update, they continue to update. I think that as we continue to move forward with these more powerful platforms where we can run more and more on device, it opens up more that the actual end user is going to be able to do here.
That's just an excellent point there. Actually, one of the key differentiating things with our unique speech to intent technology is that we were able to design systems where the end user could extend the system by giving feedback. So let's say my system is recognizing 100 commands, and I want to maybe change one of those commands in Hindi because that's my mother tongue, or maybe I want to add one more command to for whatever reason. So we are able to design a system that the user could give feedback on the device itself, and let's say something 3 to 4 times in their natural way of saying, and then the system learns on the device, could be on Cortex M4 itself, and adapts the model to from now start recognizing this. So this goes sort of Kobus towards what you mentioned, right? How do you create, or how can voice be plug and play, and then you could enable various different interfaces, right? So imagine you could have a let's say smart home management system where you don't know what is the configuration of everybody's home. Maybe people don't want to say open the door, maybe they want to say open sesame or that sort of stuff in any language, right? So we could enable that today. Actually, the slight friction there is that user does need to provide some feedback for the system to learn from that, but still the added advantage is that the learning actually could even be in a different language. I could have a system in English and I could speak certain commands to it in Mandarin or even Klingon, and the system would start to understand those just by user feedback.
I think that adaptation is key there, because you're talking about systems where voice changes, language changes over time. In fact, voice itself changes as you interface with something. If you press a button and that button is supposed to do something, it doesn't matter how you press the button. But if you get annoyed with the voice interface, your voice and tone and that frustration changes the way you're talking to it. And if you can't cope with that, then we'll never get to the point where user interfaces are used for reasons of voice because they have to be. You've got a medical issue or some reason where other types of interface aren't appropriate to a person, then voice has to be reliable.
Absolutely. And the other thing is that, even though it might sound like, oh, why would I want to do that? I'll give you an example of one of a friend. She had a car. Her last name is Langelia. So she would call, so it's Quebec French name. She would call, say, press button, voice button in the car and say, call Luc Langelia, her father. And every time it would say, call Luc, he would detect, but Langelia would get misrecognized at Cancelia, and it would cancel. So it would start dialing, automatically cancel every time. And she was so frustrated. She's like, why can I not just give feedback to my car and say, like, when I say this, I mean dial it, don't cancel it every time, right? So these small things I think would really lead to the adaptation of voice interfaces when we can improve those.
Yeah.
Thanks. I think we have a few more questions, but I think we only have time for one more. So if one person can take this one, and the question is it possible to put voice recognition into battery operated things like toys without charging the battery every day?
So I will take this one and I will leave it to Robert, because I think Robert has a lot of value to add here. One key element here we have to understand is not necessarily the computing required for the command recognition, but is the fact that the device will be in listen mode. And most of the power consumption, in fact, will come from the microphone itself. And if the engine is wake up on any ambient noise, then obviously it would draw down the battery rapidly. So here, the key challenge is to get a very efficient microphone powering, maybe in a very low power mode, and get the support of what we call voice activity detectors. Okay, that will basically filter the noise, the ambient noise from the real voice, human voice, and so limit the number of triggers to the devices. And I think, Robert, maybe then you can add a lot about what we call VED.
Yeah, I mean, you're absolutely right. Power cascade is the way of solving this one. So the answer is yes, it can be done. But you imagine you don't turn on things with more power unless you have to. So you wouldn't turn on the radio section unless you knew the keyword had gone. If you think of something like this, you don't turn on the main audio chain unless what you're listening to is voice. And in fact, there's even techniques inside the MEMS decimation chain of not turning things onto the same level. Not producing the same number of bits or quality of audio if you don't need to, in order to detect whether or not the voice is active. But with those cascade of techniques, you can make the average on time the power profile, make these battery operated devices last much longer.
Okay. Well, I want to thank all the panelists for this interesting discussion. There's a few more questions, so if some of the panelists can maybe just type the answers to those. And I want to thank everyone that attended the session, and I hope you found it very interesting. Thank you very much.
Thanks all.